In early 2026, consumer trust in generative AI fractured. A viral movement called #QuitGPT drove a 295% daily spike in ChatGPT uninstalls as users fled the platform in droves. That mass exodus was triggered by OpenAI finalizing a contract to deploy its models onto classified U.S. Department of Defense networks. Users and even internal safety leads balked at the integration of artificial intelligence into military infrastructure. At the same time, researchers realized our tools for measuring AI had broken. A global coalition released Humanity's Last Exam, a test so rigorously difficult that any question a current frontier model could answer correctly from memory was completely removed. The AI systems had memorized the old benchmarks, rendering them useless for testing true intelligence. The conversational interface, the simple text box the world spent 3 years typing into, could no longer contain or accurately measure the technology's actual capabilities. In 2026, the benchmark for intelligence shifted. It is no longer about what an AI says, but what it independently does. OpenAI recently released GPT 5.4 with a feature called native computer use. Native computer use is a capability where the model autonomously controls a mouse and keyboard to navigate operating systems, fill out spreadsheets, and execute multi-step software workflows. We saw this digital autonomy in action when an open-source agent framework navigated complex website flows to create profiles and apply for 278 jobs online. It did this completely unsupervised, simply because it determined it needed income. The economic fallout from this capability is already visible. The fintech company Block eliminated nearly 4,000 jobs, roughly 40% of its workforce, with leadership explicitly attributing the cuts to the efficiencies gained from AI productivity tools. Software intelligence has evolved from a collaborative co-pilot into a direct replacement for human administrative and analytical execution. But large language models, systems designed to predict text, have a hard architectural limit. Because they learn exclusively from language, they simply have zero inherent understanding of physical reality, gravity, or cause and effect. To solve this, former Meta chief AI scientist Yann LeCun launched AMI Labs, securing a $1.03 billion seed round. It stands as Europe's largest early-stage investment into an alternative architecture. AMI Labs is building what are known as world models. A world model is an AI architecture trained entirely on physical physics, spatial reasoning, and video data, rather than language prediction. A world model provides the mandatory software bridge required before a digital intelligence can be safely embodied inside a physical machine. This chart shows the maximum energy density of legacy liquid lithium-ion battery cells compared to the new solid-state ceramic cells. Energy density is the amount of energy stored in a given system or region of space per unit volume or mass, and reaching the threshold of 500 watt-hours per kilogram provides the prolonged power required for heavy robotics. That same solid-state architecture simultaneously unlocked extreme rapid charging capabilities, reducing a robot's downtime from hours to just 5 minutes. With the hardware and software constraints solved, AI-driven humanoid robots entered the physical workforce. BMW deployed these systems directly onto the active assembly lines of its Leipzig factory to handle physically demanding, repetitive tasks. Automakers are positioning these machines as tools for massive productivity gains. Tesla claims its Optimus robots will augment human workers, allowing the company to expand its output rather than shrink its total headcount. The convergence of physical AI world models and high-density solid-state hardware means intelligence has successfully escaped the data center. It now acts with physical agency. Zooming out to the macro level, AI is now autonomously managing and self-healing entire global telecom networks and edge computing grids. It translates broad business goals into real-time optimizations across our critical infrastructure. Sustaining this level of intelligence requires an enormous physical footprint. In 2026 alone, big tech companies are projected to spend a combined $650 billion on specialized AI data centers and compute clusters. This massive scale has fractured the industry over ethics. As governments race to integrate these models into defense systems, researchers are raising alarms over the potential for lethal autonomy operating without human authorization. Kinetic actions, which refer to the use of lethal physical force, could now be decided by a machine. The corporate responses stand in stark contrast. While OpenAI modified its internal policies to secure lucrative Pentagon defense contracts, its rival Anthropic flatly refused to lower its safety guardrails for military use. Anthropic's strict adherence to its constitutional safety principles, which ban the use of its models for autonomous targeting or mass surveillance, resulted in the company being blacklisted by the U.S. government as a supply chain risk. The risk is no longer centered on digital hallucinations or plagiarism. It is centered on the physical consequences of machines operating in the real world. As these systems gain digital and physical autonomy, the question shifts from whether they are smart enough to act to who is liable for the result.